Okay, so today we're going to learn about dividing complex numbers. But before we can do that, we need to review our complex conjugates. Complex conjugates are a pair of complex numbers of the form a plus bi and a minus bi, where a and b are real numbers. Notice the two terms are exactly the same except for the operation between them. So, for example, we have a 3 plus 2i and a 3 minus 2i. We did the same problem when we did multiplying complex numbers, but let's go ahead and look at it again. We multiply the 3 times the 3, get a 9. 3 times the negative 2i, negative 6i. Then we multiply the 2i times 3, which gives us a positive 6i. And then the 2i times negative 2i, which gives us a negative 4i squared. Alright, our next step is to combine our like terms, and we notice here that the negative 6i and the positive 6i are going to cancel, and the I squared becomes a negative 1. With that, we combine our like terms now. We have a 9 plus a 4, which gives us 13. Which brings us to something that's very important for you to remember because it's on the constructed response part of your test, is that the product of a complex conjugate pair is always a positive real number. Notice we multiplied a complex conjugate pair together and we got the real number 13. Now let's go ahead and try an example here. We're going to divide the complex number 6 minus 7i divided by the complex number 1 minus 2i. We do this by multiplying by the complex conjugate, knowing that in the denominator we are going to get a real number. We multiply both the numerator and the denominator by 1 plus 2i because what we're doing is we're multiplying by 1. Therefore, not changing the value of the initial problem, just changing what it looks like. Now we multiply both the numerator across and the denominator. In the numerator we're going to get 6 plus 12i. And then negative 7i times 1 is negative 7i. And then negative 7i times positive 2i is negative 14i squared. In the denominator, we're going to be multiplying 1 times 1, which of course is 1. 1 times positive 2i, which gives us positive 2i. And 1 times negative 2i gives us negative 2i. And negative 2i times positive 2i gives us negative 4i squared. As always, we cancel out our I squares and we replace them with negative 1. The other thing what we can do is in the denominator we can combine, the positive 2i and the negative 2i. This gives us, in our final scenario, 20 because we have our positive 6 and our positive 14 to add together, and then 12i minus 7i gives us positive 5i. In the denominator we have 1 plus 4, which gives us 5. We can then factor 5 out of the numerator and we get 4 plus I divided by 5, cancel our 5's, resulting in our final answer of 4 plus I. Now it's time to really freak you out. We're going to be putting a division problem minus another division problem. And we're going to kind of combine a couple of skills we learned in previous videos. Our first step is to get a common denominator, and our common denominator is going to be I times 4 minus I. In our numerators, remember we take the initial numerator, and then we multiply by what is missing from its denominator, in this case 4 minus I. Minus, the second numerator is 3, and then what are we missing is, in its denominator, is an I. We multiply the numerator terms together, and we're going to get 4 minus I plus 4I minus I squared minus 3I, the back term, over 4I minus I squared. Now we're going to do some combining. Notice that our I squares will then become -1. We've done that every time. So when you see an I squared, you scratch it out and you make it a -1. We also notice that we have a positive 3I when we combine these two together with this negative 3I, so those will cancel out completely. This is going to give us 5, because 4 minus a -1 is 5 in the numerator, and denominator will have 4I plus 1. Now that we've combined it into one complex number, a division problem, we can multiply by, the conjugate. Once we multiply by the conjugate, we're going to get 20I minus 5 over 16I squared minus 1. Now we're going to put it in the form, because remember the I comes in the back. It's the real part and then the imaginary part. So we're going to get -5 plus 20I. And then in the denominator, we're going to get rid of that I squared. It's going to become a -1. And so we're going to get -16 minus 1 gives us a -17. Finally, we're going to remove a negative from the numerator by taking out a -5. And we're going to get 1 plus 4I in the numerator. In the denominator, we're going to get -17. And the two negatives will now cancel, giving us a solution of 5 times 1 plus 4I over 17. Good luck, and if you have any questions, ask me in class tomorrow.